Hello everyone, welcome back. In the two previous videos on the projectile motion concept, which is projectile from the top of the tower, which we projected a particle up the from the upward in the direction upward from the top of the tower, and we also have calculated many terms like time, velocity, all that in the case of the projectile which is downward also. So in this question we have this combined case where in which we have there is a tower of height h, a point which is about height h, horizontal ground. A particle A is projected with a velocity u in an upward direction, making an angle alpha with the origin. Another particle B is projected with the same velocity u but in the downward direction, exactly opposite to A. The two particles will strike the ground. Sorry, small mistake here. Will strike the ground at a distance x apart. At the distance x apart is where they're striking the ground. So now here what you're supposed to calculate is, here we're supposed to calculate what is this x distance. So that means for that we have taken the diagram here. If you observe, there is a particle that is projected downward with velocity u, making an angle theta alpha with the horizon. This is the horizon, the horizontal line, and the same thing here again, making an alpha up the tower upwards. So in this case, I've taken the distance, the horizontal distance that is traveled by the particle B or particle A. You can particle B is x1 because it is in the downward direction, and particle A is in the upward direction, which is taken to be equal to x2. Now these x1 and x2 are the horizontal distances. So can I directly write it like this? The total distance is x is equal to, I can write it as x1 plus x2. Now here a very simple rule we can follow. What is that simple rule? Here I can take the value of x2 is equal to the horizontal component of velocity, which is u cos alpha, into the time taken for it to reach the ground. I take it as t2. And here similar way I can take it also. For x1 is equal to, I take it as u cos alpha into the time taken for it to reach the ground, which is time of flight, which is t1 I take. So in the previous videos we have already clearly learned what is the time taken when you project an object upward. That is, I consider it as t2 is equal to u sine theta by g, means the angle of projection is alpha, so I take it as u sine alpha by g plus root of u square sine square theta by g plus 2h by g. Similar way for time t1 also we have a formula. We derived this actually in the previous videos, which is t is equal to u minus u sine alpha by g plus root of u square sine square theta divided by g square plus 2h by g. We have derived these equations. Please refer to the previous two videos. The link will be provided in the description also. So in these two times I know, now I have the relation for x1 and x2 also, so that I can write total distance x is equal to x1 plus x2. Very clear. Now x is equal to what I can write is, x is equal to x1 value is u cos alpha into t1 plus u cos alpha into t2. Now I know the value of t1, I know the value of t2. Just substitute the values of t1 and t2 here. So what I'll get here is, substituting the values of t1 and t2, and as well as if I take u cos alpha common out, what I'll get is x value is equal to, I get it as u cos alpha taken common out, I'll get t1 plus t2. I'll get t1 plus t2. Now here I have the value of t1 plus t2. I know the value of t1 and I also know the value of t2. So add them both. Here what is the t1 value I get here is, I get it as x is equal to u cos alpha into minus u sine alpha divided by g plus root of u square sine square, sorry, this is alpha, my mistake, this is alpha, this here also is alpha only. So u sine square alpha by g square plus we have it as 2h by g, where it is 2h by g, and further I'll just add other plus u. Just a second. Just place it a little aside so that x is equal to so much, and plus I have the term as u sine alpha by g plus root of u square sine square alpha by g plus 2h by g. So here I can cancel out u sine alpha plus g minus u sine alpha plus g, and what I'll remain is here with I'll remain with x is equal to u cos alpha. I'll remain with u cos alpha into, if I take here g common out, I'll be remaining with g means g in the sense I take g common out, and I'll have 2 by g into here 2 by g. If I take common also, what I'll get, or else I'll just write it like this. I'll just take it like this: 2 into root of u square sine square alpha by g square plus 2h by g, 2 into root of so much. And now if I take the g common out here, I get what I'll get is 2u cos alpha divided by g into root of u square sine square alpha, g square taken common out, under the root it is, so it will come as g, and sine square alpha plus 2gh. So this will become the total distance between the two particles when they are projected from the height h with same initial velocity, one projected downward, the other projected upward, making a same angle of alpha with the origin. This is the answer for that: 2u cos alpha by g into root over u square sine square alpha plus 2gh. Hope you understood. Please be following us and sharing, commenting our videos. For more such videos, you please support us. Thank you.